drab, boring, black and white. This must be how people with colorblindness see the world. Well, that's incorrect. People with colorblindness see the world a lot more like this. But before we can understand how colorblindness works, we first have to understand how color vision works. You see, your eye contains over 125 million photoreceptors, cells that send a chemical response to the brain whenever they detect light. Out of these, 5 million are cone cells, which allow you to see in color. The 3 varieties of cone cells are named based on the wavelengths of light that they respond to. L, long cells, which allow you to see red, M, medium cells, which allow you to see green, and S, short cells, which allow you to see blue. When light of a certain wavelength, for example 540 nanometers, hits the fovea centralis, the area of the eye where the cone cells are concentrated, M cone cells are triggered, causing you to see green. Many wavelengths trigger more than one type of cone cell. For example, a wavelength of 600 nanometers triggers both red and green cones, which your brain interprets as orange. Different wavelengths triggering different combinations of the 3 cones with different intensities is what enables us to see so many distinct colors. In most types of color blindness, however, the cones respond to different wavelengths of light. The most common form is red-green color blindness, which affects around 8% of European males. The 2 types of this are deuteron anomaly, where the range of wavelengths that trigger the M cone shift closer to red wavelengths, and proton anomaly, where the wavelengths of light that trigger the L cone shift closer to green. This can cause many colors to be difficult to distinguish and may even make it impossible to see certain colors. Other, much rarer forms of color blindness include triton anomaly, blue-green color blindness, dichromacy, where one cone is missing entirely, and monochromacy, where 2 or more cones are missing. Most of the time, color blindness is inherited. The genes responsible for color blindness are recessive and on the X chromosome. This is why 1 in 12 males are colorblind, but only 1 in 200 females are, as they have another X chromosome which has a chance of carrying the dominant gene for normal color vision. Colorblindness is an extremely common condition, which almost certainly affects someone you know. Despite this, there are many misconceptions to how it works. Hopefully, I was able to clear some up.